We're going to be talking about what a VLAN is, why we need a router in the first place, how we configure inter-VLAN routing. Cisco calls it router on a stick. I did not make that up myself. And troubleshooting inter-VLAN routing. Let's go in and talk about what a VLAN is a little bit further. So here is a switch, and I've created some VLANs on it on the slide anyway. It's not a real switch, it's just a drawing of a switch. We've got VLAN 1, which is the management VLAN, and that's where the IP address of the switch is in existence. And then I've put ports 1 through 4, so we've got VLAN 2, and it's the blue VLAN, and we've got ports 1 through 4 in VLAN 2. We've got VLAN 3, which is the red VLAN, and that's got ports 5, 6, 7, 8, and 9. And we have VLAN 4, which is the green VLAN. Notice the color coding going on here. And ports 10, 11, and 12 are in VLAN 4. Now, what a VLAN is, and I talked about it in the VLAN slide, or a VLAN video, is a broadcast domain. So what that means is if computer B1 sends out a broadcast message, the switch will only forward that broadcast message to the other computers within the blue VLAN. It will not allow traffic to pass from the blue VLAN to the red VLAN. So all computers in their respective VLANs can talk to each other, but their switch will not allow any communication between VLANs. The only way we're going to be able to get some communication between the VLANs is by routing in between the VLANs. So what we need to do is we have to get a router. Here is a very realistic picture of a router with an interface in each VLAN. So we can do a router with an interface in each VLAN. And what we could do, there's a few different ways, well, there's a couple different ways we can do this without a layer 3 switch. Some switches have the ability to be a router and a switch. CCNA focuses on a switch that just does switching. It's not a router and a switch, it only does layer 2 function, no routing. Theoretically, I could have a router with an Ethernet 0, an Ethernet 1, and an Ethernet 2 interface, and maybe have an extra interface here in each VLAN, and plug each one of these Ethernet interfaces on the router into a port on the switch that's a part of each VLAN. And so what would happen is this computer would have this gateway, red computers would have this as a gateway, blue computers would have that as a gateway. So if they wanted to talk to each other, they'd send it to their gateway, router would look at the IP and determine which interface to send it out of, and that would work perfectly fine. The only thing is we'd have to have a router with multiple Ethernet interfaces, and it's not totally necessary. We can configure what's called a sub-interface on a fast Ethernet port. Let's take a look at what the heck I mean by that. I have drawn up another slide, and I put another interface on there, interface 13, and it has a connection, this is just a cable right here, to interface FA00 on a router. It's a fast Ethernet interface. Now, all these right here, this .1, .2, .3, .4, this whole thing is fast Ethernet 00. These are what are called sub-interfaces, and I will show you how to configure those. What happens is we assign .1 sub-interface to VLAN 1, and we would put an appropriate IP address there. .2 interface to VLAN 2, .3 interface to VLAN 3, .4 interface to VLAN 4. Let me throw some color in there so we can see what interface goes with what VLAN a little bit more easily. So there's VLAN 1. Here is VLAN 2, blue. That's VLAN 2's gateway or sub-interface. Here is VLAN 3's sub-interface, the red VLAN. and VLAN 4, the green VLAN. So each sub-interface here is associated with a particular VLAN. What we would need to do is we'd have to have an IP addressing scheme that functioned appropriately with the way we have our VLANs laid out. So VLAN 1 might be 20.1.0.0. And VLAN 2, the blue VLAN, might have a subnet of 20.2.0.0 just to make it easy. VLAN 3, 20.3.0.0, and VLAN 4, 20.4.0.0. The router needs to have separate IP or separate subnets for each broadcast domain so it can actually route in between these broadcast domains. Every broadcast domain needs to have a different subnet address. That's the only way the router knows if a packet needs to go out of subinterface 1, subinterface 2, or 3, or 4, is because the subnet address tells the router which interface a particular IP address is going to need to go out of. So this IP address on the .1 interface here would be 20.1.0, and I could put .1. For the .2 interface, I could put 20.2.0.1, 20.3.0.1, 20.4.0.1 down here. And then each computer would need to have an IP address appropriate for the subnet that it's in. I'm going to go into the simulator and we're going to set this up. I'm going to go in and assign all the IPs to the computers, even though I'm not going to throw 12 of them in there. And we'll take a look at what we have to do to the router to get this to function appropriately and have communication pass back and forth between the VLANs. So let me bring up my simulator. Here is my trusty simulator. I've gone in and let's take a look at the switch. I'll do a show running config. Again, I just type show run because I'm lazy. And I can see that fast Ethernet 01, port 1 on the switch, is a part of VLAN 2, which is the blue VLAN. Port 2 is a part of VLAN 3, which is the red VLAN. And port 3 is a part of VLAN 4, which is the green VLAN. I've also configured an IP address on the switch to be a part of the management VLAN, which is VLAN 1. If I do a show VLAN, I can see that I have VLAN 1, which is the default, and all the ports are in it, as well as the switch IP, which is an interface VLAN. And I created a number 2 VLAN called blue, a number 3 VLAN called red, number 4 VLAN called green. Port 1 again, VLAN 2, port 2 is in VLAN 3, port 3 is in VLAN 4. And I've plugged the corresponding computers into the appropriate ports. Now I've also gone in and configured the router. Not fully configured the router, but I have gone in, given the router a name, and left the interface blank because that's what we're going to be going in and configuring. So I guess I haven't configured it too much yet. The computers, PC blue, I've gone in and configured an IP address with this command, 20.2.0.2. And this guy has an IP address that's 20.3.0.2 for that appropriate VLAN, and PC green has an 20.4.0.0, that's inappropriate. 20.4.0.2 IP address. And let's take a look at what we're going to do to the router real quick in my slide. I've redone my slide here to show us what's going on exactly. Here is the switch. Here is router Palestra 1. And this is the way it's cabled. Port 12 on the switch is connected to port FA00 on the router. This stuff does not exist yet. So it connects directly to port FA00. This is simply a cable here. It's just a really thick cable. Now I have a PC. That's the blue PC. I went in and showed you the IP address, 20.2.0.2, and it plugs into port 1 on the switch. That port is a part of the blue VLAN. The red PC, 20.3.0.2, plugs into port 2, which is a part of the red VLAN. 2402, which I had to fix just now because I mistyped, is a part of the green VLAN, and that's plugged into port 3. What we're going to be doing is we're going to be turning on trunking. And if you can remember from the VLAN video, trunking tells the switch to encapsulate the packet, or frame I should say, with VLAN tag headers. And again, we can use ISL or 8021Q. If we're using ISL, it says, hey, this package is a part of VLAN 1. Or if it's a part of VLAN 2, it'll say, hey, this package is a part of VLAN 2. Whatever the case, we have to turn trunking on the switch and on the router. We have to tell the router how to listen to the trunking information and repackage it appropriately. So what's going to happen when PC blue wants to talk to PC red? You can't just go through the switch right here and loop back around. It's got to go through the router. We'll type in let's say we do a ping. We type in ping 20.3.0.2. What's going to happen with this machine right here? What's he going to do? First thing he's going to do is he's going to look at this IP address and compare it to his subnet mask and realize that the subnet that machine is on the 20.3 subnet, not the 22 subnet. So what's he do when the machine is not local to his subnet? He's going to send it to his gateway. Now what we're going to have to do on the router is we're going to have to configure a gateway for each one of the machines, basically for each VLAN or each broadcast. I mean, there'll be a .1 sub interface, and what it is we actually chop FA00 here up into 4 parts. Each part acts like a separate physical interface. We can configure it with an IP and everything. So PC Blue's gateway is going to be 20.2.0.1. And it's going to be a part of the blue VLAN. So what happens is he sends it to his gateway. So it goes here, goes through the switch, and then the switch is going to send it over to the router. But before he does, he throws some packaging on the information there. He says, hey, here's my package. It's going to the gateway, which is the MAC address of the router here, but there's a trunking turned on this interface, so I have to tell the device what VLAN this is a part of. This package is a part of VLAN 2. CRC stuff in the black here, fully encapsulates it, sends it out. The router sees this VLAN 2 information, goes, okay, that's got to go in through this sub interface right here, pulls it in through this sub interface. Then he goes in and strips that information off, looks at his MAC address, strips that information off, and gets to the IP addressing information on the inside, gets rid of all this extra junk, gets to the IP information. And he sees that 20.3.0.2 IP is a part of the red VLAN 2302, and he'll actually have a full routing table here, and it'll say 20.3 subnet. That's got to go out of interface FA0/0.3. And so he'll go, okay, that's got to go out of this interface. So he'll package it up again at layer 2. He will get this machine's MAC address and put it in there. So it's all packaged up, ready to go. And he goes, oh, wait, this is a trunk. I also have to tell the switch that's going to receive this what VLAN it's a part of. And so he knows now that VLAN, the red VLAN is VLAN 3, so he'll put VLAN 3 on there, package it up fully, and send it out to the switch. The switch gets it, says, oh, this is VLAN 3 traffic, strips that information off, looks at the layer 2 frame, goes, oh, that's got to go out port 2, sends it to the switch. So a bunch of extra stuff has to happen here for this to function. Let's go in and configure it on the switch and on the router. All we have to do to the switch is turn trunking on right here. And then on the router, we've got to create 4 sub interfaces and make sure that they're trunking appropriately. Let me bring up that simulator. I have my simulator up here, and on the switch so far, I have pre-configured it. If I do a show running configuration, I can see that Interface 1 is a part of VLAN 2, which is the blue VLAN. Interface 2 is a part of VLAN 3, which is red VLAN. Interface 3 is a part of VLAN 4, which is the green VLAN. I have also configured an IP address for VLAN 1 on the switch. Remember, the switch's IP can be in VLAN 1, and that IP address is 20.1.0.1 for the switch. And I have created VLAN 2, VLAN 3, and VLAN 4. The computers are plugged into the appropriate ports, and I have given the IP address of the blue machine 20.2.0.1, and actually I want that to be 20.2.0.2 because the gateway is going to be .1, so I just changed that. Red machine has an IP address of 20.3.0.2. Green machine has an IP address of 20.4.0.2. And the sub interfaces on the routers, which will be their gateways, will be .1 addresses instead of .2. So the first thing I want to do is I want to go to the switch interface that's plugged into the router. If I do a show run again, I can see that interface FA012 has no configuration on it, and that's the one that connects to the router. I need to go in and turn trunking on. If I wanted to verify that that's the interface that's plugged into the router, I could just show CDP neighbors, and right now the router's probably not turned on, so it's not showing up. But if the router was turned on and I hadn't turned trunking on yet, I could do show CDP neighbor and verify that that's the connection. I happen to know that's the connection because I just set it up that way. So we're going to go to interface FA0/12. I'm going to turn this into a trunk, meaning before it sends any information out of this interface, it's going to put some VLAN information added onto that particular package. So we're going to go switch port, mode, trunk, and turn the trunk on. So the trunk is now on. If I do show interfaces trunk, I can look at that information. And it's showing me here, here's my trunk. FA012 is a trunk. It's allowing all the VLANs 1 through 4094. Here's the ones that are actually functioning, 2, 3, and 4. And the encapsulation is 802.1q, not the Cisco proprietary ISL. So the way it's putting the VLAN information on there is using the 802.1q set of rules. That means when I go to the router, I have to make sure that the router uses the same set of rules. If I use something different, it wouldn't function. So all we have to do now is go to the router and configure the sub interfaces on the router. If I do a show run, I can see that fast Ethernet 00, no IP address, which is good. It's showing that it's fast Ethernet speed, and it's shut down. We need to go turn that on. So let's go in and interface FA0/0, no shut. And I want to configure the sub interfaces. You don't see sub interfaces in here right now. All I have to do is go interface FA0/0.1, and notice it creates the sub interface and takes me to configure the sub interface, all with that one command. So now that I'm at the sub interface, I want to go in and configure it. Encapsulation command, and here's where I specify. I could do ISL, which is the Cisco proprietary, but we're going to be using .1q because I have to match what the switch is using. So I'll go let's tab that out, .1q, and then I have to say, hey, this is going to be associated with VLAN 1. So interface FA0/0 is a part of VLAN 1. IP address 20.1.0.1. That's the gateway for the switch. Now I'll go back to FA0/0.2 now, and I created another sub interface. This is going to be associated with VLAN 2. And I'll go in and give this an IP address of 20.2.0.1. And that's for the blue VLAN. Same thing, I can use my up arrow to bring up my previous command, or Control P makes it real easy for me to go in and configure this. Interface FA0.3 is associated with VLAN 3. Specify the IP address of 20.3.0.1. And configure the last sub interface of for VLAN 4 with the appropriate gateway IP address of 20.4.0.1. Show run. Check it out. I see everything there. So I can see that interface FA0/0.1 associated with VLAN 1 and has this particular IP address. So that looks good, and I can see it's appropriate for every sub-interface. Very important to verify the IPs, verify to make sure the appropriate VLANs associated with the right interface. Otherwise, it's not going to be able to communicate. Show IP route. Can't hurt to check out my routing table and make sure I see all my subnets. If I don't see all my subnets in here, how's it going to route? I do not have to put in a routing protocol now. I don't have to do anything because since they're all directly connected subnets and IP routing is on by default, it'll automatically route. So I see 21 goes out through this sub interface. 20.2 subnet, appropriate sub interface, 20.3 subnet, and 20.4 subnet. So I know that the routing should be functioning. Now what I'm going to do is go back to my switch and make sure that my switch can ping the router. 20.1.0.1. See if it can ping its own gateway. If I've even set it's there. So I haven't actually set the switch gateway yet, but I'm only going to have to do that if I want the computers to be able to ping the switch. I'll go in and set the switch's gateway right now. IP default gateway 20.1.0.1, which is the router. And again, it can't hurt to do a show run real quick again. Make sure I can see my gateway there. I see my IP address. Uh-oh, it was pinging itself. Again, very important to make sure you got the right IPs. If you don't, you're going to run into problems. So pay attention to that. Don't make simple mistakes like the ones I'm making here. Otherwise, you're going to run into problems. IP address 20.1.0.2. Very important to check those IPs. I see a lot of problems with IP and people not being careful as far as what IPs they're typing in. Can I still ping my gateway 20.1.0.1? Alright, now that I can ping the router and I know the switch's IP is 21.0.2, I know that trunking is functioning. If we look at our net map here, I can see that there is a trunk between the switch and Palestra 1, and it is working because I can ping from here to here. If trunking wasn't working, or the ISL encapsulation or 8021Q encapsulation didn't match, then I wouldn't be able to ping back and forth. So I know I can ping. Now let's check out some computers here. PC Blue. Check out the IP addressing information, and for this to function, I'm going to have to set the gateways because that is not an appropriate gateway. So I'm going to go in and configure the gateways on these machines real quick. I've gone in and I set the gateway on the machines, and since I have a gateway set on every machine, everything's configured now, I should be able to ping from one machine to another. So I'm on, let's go to PC Blue right here. I'm on PC Blue. I should be able to ping any of the other machines. So 20.3.0.2, which is the red PC, I should be able to ping that. I can ping it. 20.4.0.2, which is the green PC, I can ping that, and I should also be able to ping the switch, which is 20.1.0.2. Excellent. So I can ping throughout my network here. So again, taking a look at this, what we've done is I can ping from PC Blue to the switch, PC Red, PC Green, and it's going through the VLAN motions. Let's go back to our diagram and do a recap of that real quick. Here's our diagram. We've got 3 machines down here with different IP addresses. So here's machine 1. It's part of VLAN 2. Remember, this is the blue VLAN. I'm going to write blue. This is the red VLAN. It's part of the red VLAN. And this is the green VLAN. It's part of the green VLAN. So I've got VLAN 2, VLAN 3, VLAN 4. Appropriate IP address is configured. And the port on the switch for port 1 is part of VLAN 2, which is blue, port 2 part of VLAN 3, which is red, port 3 part of VLAN 4, which is green. That's why I did that little color coding there. Help us remember what VLAN each of these is a part of. And then on the switch, we turned trunking on. And that used 802.1q encapsulation. So we did switch port mode trunk. That's the only thing we configured on the switch because the VLANs were already present. Then on the router, we went to FA0/0 and we typed in 0.1 and created the sub interface right here. And we typed encapsulation encapsulation 802.1q and then 1 for VLAN 1. And we did this same thing here. Encapsulation 802.1q 2 for VLAN 2, encapsulation 802.1q 3 and 4 for the appropriate VLAN. So what we did was we associated a VLAN with each interface by typing in that encapsulation 802.1q command, and then the VLAN number. Has nothing to do with the number of the sub interface. This number, VLAN number 2, does not have to match the sub interface of 2. It just makes it easier. This could be 200, whatever. You can create as many sub interfaces as you want. I've created sub interface 30,976 before just to see if I could do it, and it allows me to do that. So we associated the sub interfaces with the VLANs and we gave them appropriate IPs. So 20.2.0.2 machine's gateway is 22.0.1 IP. And then we tested connectivity. For this machine to be able to ping the red machine right here, it's going to have to go through the router. It's going to get routed. So again, what happens is when this machine types ping 20.3.0.2, this blue machine is going to go, whoa, that's not in my subnet. That's in the 20.3 subnet. I better send it to my gateway. So he takes this IP package with that IP address in there and puts the router's FA00 MAC address on there and sends it out. The switch takes it and goes, oh, that MAC address has to go out the trunk port. Before I send it out of the trunk port, I better put some more information on it. This is coming from VLAN 2, it tells the router. So the router bringing it into the interface and looks at this information, goes, oh, that's got to go in through this sub interface right here, and he strips that data off. Reads the MAC address, strips it off, looks at the IP information, and goes, whoa, that's 20.3.0.0 subnet. That's got to go out of this sub interface right here. Okay, let me repackage it up. So he takes the IP packet, finds red machine's MAC address, puts the MAC address in there, and then before he sends it out of the interface, puts the 802.1q information on there that says, hey, this is coming from VLAN 3 and it's going to VLAN 3. Just so the switch knows it's coming from the router's sub interface that's a part of VLAN 3 and it's destined for VLAN 3. So it goes in there. Switch sees this information, goes, okay, that's VLAN 3. It can only go out other ports that are part of VLAN 3, strips the data off. Checks the MAC address and goes, hey, do I have a MAC address in my forwarding table? That's got to go out. That's a part of one of the ports that are associated with a port that's in VLAN 3. And he goes, I do. Port 2 here is associated with VLAN 3, and this MAC address is associated with that port. So let me send that information out. So he sends it out. The computer just looks for his MAC address, and he sees it, opens it up, gets to the data, sends a response back. If you'll notice, all of the VLAN information is stripped off before it hits the computer. These guys are oblivious to the fact that they're a part of a VLAN. They do not know what a VLAN is. They're ignorant of the fact that a VLAN exists and that they're a part of one. Very important to remember that, because if I take this computer 2, and I unplug it from port 1, and I plug it into another port, let's pretend that this is port 4 right here. They just numbered them out of order. And port 4 was a part of the red VLAN, VLAN 3. This computer would no longer be in VLAN 2. It would now be a part of VLAN 3. So it's the port that the computer plugs into with static VLAN membership that determines what VLAN the machine is a part of. Let's go back into the simulator and use our show commands and figure out what steps we would take if we were having trouble with this Inter-VLAN routing. In my simulator, if I was having trouble with this Inter-VLAN routing, I wouldn't necessarily check this in my simulator to have it written down somewhere, but the first thing I would check is my documentation, and I'd verify that the machines are plugged into the right ports, and I would try to ping the gateways. If the machines couldn't ping the gateways, then I'd go in and figure out why they couldn't ping the gateway. And an area of concern would be this trunk. If the trunk was not upright, then blue, red, green machines could not ping their gateway. So what I would do on the switch is I would do a show interfaces trunk command, and I would make sure that the trunk is on, and it says it's on. I could even do a show interfaces FA0/12 and make sure the interface is up and line whoa, easy. The interface is up and line protocol is up. It looks good, so that's a good sign. So I'd want to make sure if this was down or the trunk wasn't on, I want to go and figure out why. I could also do a show MAC address table and check to make sure that the MAC address for the computer was associated with the right port. That's kind of a way for me to make sure that the computer is plugged into the right interface. If it wasn't, it wouldn't work. So your cabling can be very important. I could also do a show VLAN, make sure I had the VLANs set up right, and that the appropriate interface was in the appropriate VLAN. So you got to make sure your computer is plugged into the right port and that the interface is in the right broadcast domain. So I can go in here, check that information out. I can also do a show run, just check out all my configuration down here, interface VLAN 1, okay, the IP is good. Check out my VLANs that are created. Now it's important, I think, to keep the switch in interface VLAN 1 something that's separate from your computers, because that way I can use that for troubleshooting purposes. And again, since I can ping 20.1.0.1, I can ping that IP address, which is the gateway. I know that that trunk is good. If the trunk wasn't good, I could also go over to the router. Check that out. Show run. I usually just do a show run on the router or show interface FA0/0 on the router to make sure the interface is up and up. I always want to check to make sure interfaces are up and up. If they're not, there's a problem there. Show run allows me to go in, and I gotta look carefully here. If the IP is wrong, won't function. The machine won't be able to ping its gateway. Encapsulation, .1Q, has to match the trunk on the switch. So if I do show interfaces trunk, I see it's using .1Q. Got to make sure it matches. I've got to make sure that the sub interface is associated with the appropriate VLAN. And this, again, documentation key here, and have it written down well, because you want to be referring to your documentation. Because once it's configured, you might not touch it for a while. So that way, very important to have it well documented. So when you do have a problem, go back in, check your documentation, make sure everything's right. IPs, VLAN information, everything. And also make sure your computers, sometimes people might go in and mess their computer up. Just because their computer can't communicate doesn't mean the VLANs are down. Maybe the IP problem is at the computer, or the gateway IP address isn't typed in right, things like that. So again, very important to check everything out. VLAN, IPs, all of that. Any of those things being off could cause a problem. Let's go back to our slide and do a recap of what we've gone over. So we went in and configured our VLANs. We used some commands here on the switch. Switch port mode trunk, turn trunking on. And again, when we did that, we did a show interfaces trunk command and made sure that The encapsulation was 8021Q. It was. Made sure the trunk was on, all that. Show MAC address table allows us to do some troubleshooting. Verify that the machines are plugged into the right ports. Show VLAN allows us to check out our VLANs, make sure that they're created in the right interfaces or in the right VLAN. And on the router, we went in and used the interface FA0/0.X. I didn't actually type in X, I put a number there. Again, 1234 for VLAN 1234. Does not have to directly relate to the VLAN, but just makes it nice. Again, that creates the sub interface. It says config sub if. Stands for sub interface in the router when we do that. After we type in interface FA0/0 point whatever, we type in the command encapsulation.1Q and then the VLAN number. So that associated the appropriate VLAN with the right sub interface, and then we gave it an IP address. In this video, we have talked about inter-VLAN routing, did a little refresher of what a VLAN was, why a router is needed, again, so we can have communication between those machines. We configured router on a stick, and we did some troubleshooting.